This question is from GATE 2015, Mechanical Engineering paper, Set 3, question number 28. Figure shows a single degree of freedom system. The system consists of a massless rigid bar OP hinged at O and a mass M at end P. The natural frequency of vibration of the system is. As shown in this figure, the deflected rigid bar OP will have a single degree of freedom, which is theta. So we have a generalized coordinate theta here. We'll form the equation of motion of this system using Lagrangian method. So EOM, short for equation of motion, will be given by d by dt, that is time derivative of dl by d theta dot, partial derivative of Lagrangian with respect to the angular velocity, minus dou L by dou theta equal to 0. That is partial derivative of Lagrangian with respect to the angular displacement theta, where L is the Lagrangian defined as kinetic energy minus potential energy of the system. So first thing, let's find out the kinetic energy of the system. Kinetic energy will be possessed only by the mass because the spring when expands stores potential energy. It does not have kinetic energy, it has potential energy in it. The only entity that possesses kinetic energy in this system is this mass M. OP is also massless, and that's why it will not have any kinetic energy. Kinetic energy of this mass M can be written as half into small mass m into its velocity square. Now velocity of mass m can be written as the time derivative of its displacement. For the spring we had the displacement of xs. For the mass we can denote it by xm. Both will not be equal. Notice this point. Xs is this small distance. The deflection of the bar at Q will denote xs and the deflection of the bar at P will denote xm, which will be the displacement of point mass m. Half into m into V will be given by xm dot whole square as per the definition of velocity. From this figure, xm, because theta is a small angular displacement, we can write the relation xm is equal to 2 times a into theta. This distance into theta, it is nothing but s is equal to r theta, and xs can be similarly written as a into theta. So xm dot will be 2a theta dot, because 2a will not have a time derivative, it's a constant. Theta will have a time derivative theta dot. Hence we can write the kinetic energy as half into mass into xm dot, that is 2a square theta dot square. 2a square theta dot square. So this can be written as 4ma square by 2 into theta dot square, which is 2ma square theta dot square. Similarly, we can find out the potential energy. Potential energy will be only possessed by the spring because we do not consider this change of height of m, which is very small, xm. That is why we'll only take the potential energy of the spring, which will be half into k into deflection of the spring square of it. Xs can be written as a theta. We'll write it here, half into k. K here is the kinetic energy and this k is the stiffness of the spring. Notice this. Into xs will be a square theta square. So potential energy of the complete system is given as ka square theta square by 2. We have the kinetic energy, we have the potential energy. We can find out the Lagrangian. Lagrangian will be just the difference of the two. We'll directly put the Lagrangian value in the equation of motion to frame the equation of motion. So as per equation of motion, it is d by dt of partial derivative of L with respect to theta dot. The only term having theta dot is kinetic energy. So it will be 2 into 2, that is 4 ma square theta dot, minus dou L by dou theta. So there is already a minus with the potential energy. So the derivative will be minus. What we got was ka square theta square by 2. So it is ka square theta here is equal to 0. Taking the time derivative of the first term, we have ma square theta double dot plus ka square theta equal to 0. Now by definition of natural frequency, that is omega n, we have omega n is under root k star upon m star. K star here is the stiffness equivalent coefficient of theta, and m star is the mass equivalent coefficient of theta double dot, that is angular acceleration. Just putting the values we have is equal to root over Ka square upon 4ma square, which is nothing but root over K by 4m. We are asked in the question to find out F. This is the angular velocity. So essentially omega n is being given as 2 pi into F. So F can be given as omega n by 2 pi. Therefore F is 1 by 2 pi under root K by 4m. This is our final answer. Let's mark the correct option. So the correct option is option A. Fn is equal to 1 by 2 pi root over K by 4m. To learn more about generalized single degree of freedom systems, you can refer to the NPTEL video, Module 1, Lecture 17, Generalized Single Degree of Freedom Systems, Equations of Motions, from the course Structural Dynamics. It is by Dr. P. Banerjee. He is from Department of Civil Engineering, IIT Bombay. I hope this solution will help you clear your doubt. Thank you.